Well, I'm really excited to have this discussion. I want to dive right in. I think a lot of us are pretty accustomed to the idea that our computers are going to be very smart, they're going to do lots of work for us. But I'll be honest, it was kind of new to me, this idea, outside of science fiction, that it was going to be reality that computers might have conscience or emotions. We think of those as things that are reserved for humans. Why will they, and how will that happen? So paint a picture for what that might look like with a few more years of computing power. Maybe we'll start with you, Professor.
It is true that even in my own field of artificial intelligence and computer science, there are people who say computers are not going to have emotions and consciousness and so on, and I have disagreed with that for 3 decades or so. In principle, I think we already have simple machine learning systems that develop emotion and consciousness just as a side product, as a byproduct of problem solving. And let's start with the easiest part, which is emotions. There is an old traditional field of machine learning which is called reinforcement learning. And what is it about? Well, suppose you have a robot that doesn't know much about the world and it has to learn to interact with the world to achieve certain goals. Now, how do you protect this robot from itself? Well, you give it pain sensors. You equip it with all kinds of sensors, and whenever it bumps against an obstacle, then there's a negative number coming from the pain sensor. And there are all these negative numbers coming from all these pain sensors also in the battery. Whenever the battery load is low, then you get negative signals. And the system doesn't like the negative signals. And it's wired up.
And I want to stop you right there, because this is a key point. I think we all get that the robot is learning not to bump into things, and that it knows it needs to recharge itself. I think where most people haven't yet opened their minds, certainly I haven't, is this idea that it's actually feeling pain as opposed to just has an instruction to go do that. Talk about the difference between those two.
Yes. So how do you decide whether somebody really feels the pain or only acts as if he feels the pain? Behaviorally, our little learning agents act emotionally because in the beginning they don't know how to avoid the pain, but then they have a learning algorithm on board, and they figure over time, they figure out how to change the internal connections in their little artificial brains such that there is less pain coming in and more reward is coming in. So all they are trying to do is just maximize the sum of all the positive pleasure signals and minimize the sum of all these pain signals over their lives. And this is an old thing, it has been done for a long time. And from these primitive emotions, avoiding pain, you get all kinds of secondary, more complex emotions as a byproduct. For example, suppose there's a little robot now, and there's a guy, whenever he opens the door and comes in, he goes to the little robot and knocks him on the head. And over time, the robot learns that there's a way of avoiding that by doing face recognition, and whenever the same guy or a similar looking guy comes in, he is trying to hide behind the curtain. And it's a totally rational consequence of maximizing the reward and minimizing the pain signals. And it looks like a secondary emotion because now the guy really looks as if he is afraid of the person that is always knocking him down. So Alexander, all of this emotion is just a natural consequence of problem solving, but the problem is try to get as much reward as you can.
Yeah, Alexander, are these really emotions or are they just good computation?
The thing is that what I also have the problem with many people who are asking that, I think we can state one fact that there are different levels of consciousness. So people always think of consciousness like a human level, which is really highly developed. What Jürgen just mentioned is like a lower level of consciousness, which we can agree, and we don't know if it pretends or if it really has this, but it's kind of a consciousness. But how far is the way then actually from these feelings you pretend or you really have, which are a lower level of consciousness, towards an actual self-consciousness, where you look in the mirror like a monkey and you see that's maybe you, from this lower level of I just feel pain and I need to do something different to increase my reward?
Yeah. So we haven't talked much about consciousness yet, only about these emotions. And then the point is that as you are observing the organism which you are judging, does it have emotion or not, you are relating to your own experience. Now, there is nobody who has a mathematical definition of emotion. However, most people who see a little robot that is obviously afraid of another guy trying to hurt it, they will say, well, that looks like emotional behavior. This little guy is afraid. Or another guy is helping the little robot all the time, and so the robot is going to be attached and is going to have positive feelings toward that guy, and it's going to show because he will seek he will seek to be near this source of pleasure and reward. But we haven't talked about consciousness yet. For consciousness, you need yet something else.
And that is?
Yeah. Well, so consciousness is about, first of all, we can play the fact that there is no universally accepted definition of consciousness. However, I think it's rather easy to build a little system that exhibits behaviorally all the things that people think are fundamental for consciousness. So how do we do now, how do we create a conscious little agent? We have done that for many years. Think back of the robot with the pain sensors and so on. It's trying to adjust the connections in its internal little brain to become a better problem solver, always trying to reach the charging station whenever the battery is low without bumping against the obstacles that lead to pain. Now, we give this little robot an extra recurrent neural network, which is just trying to predict what's going to happen if I do that and that. So it takes all the data that ever comes in and just becomes a prediction machine of the future given the past. And as it is trying to predict what's going to happen next if I do that and that, it's actually performing something which is called data compression. Because whenever you can learn to predict something that you couldn't predict before, then you can better compress the data. So first you need so many computational resources, neurons and bits of information to encode the data, and afterwards you need so many. What is happening there? The system is becoming a better predictor. Everything that you can predict, you don't have to store extra. Yeah. Everything you can predict, you don't have to store in an extra part of your storage, which means that you can save computational resources. Now, what is happening as this agent is interacting now with the world and is creating more and more data that can be used to train this model of the world, which is a recurrent neural network such as LSTM or something like that. What is happening there? The system in the beginning knows nothing, but then over time it develops internal little connections and sub-programs, sub-routines, if you will, that stand for all this stuff that frequently occurs in the world. For example, in a world where there are lots of glasses, it is really efficient to create something like an internal sub-program that stands for a prototype glass, and a new glass comes along, and you perceive the new glass, and it makes a lot of sense to just have something like a prototype glass, and a new glass comes along. You just have to encode the deviations from the prototype.
Sure, and so, I just want to speed things up a little because I know short on time. Oh, you want to finish?
Same for faces. So if you have a prototype face, you have learned from lots of examples of faces how to build a prototype face. A new face comes along, you only have to encode the deviations from the prototype face. Okay, now this neural network is creating all kinds of internal sub-programs and symbols that stand for the frequently observed things. And there's one thing that is always active as the agent is interacting with the world, which is the agent itself. So it's really efficient for data compression reasons for this neural network to develop an internal symbol, an internal subprogram that stands for the agent itself and all the consequences of its actions. And now, the first guy who is selecting the actions to create the data that is shaping its knowledge of the world, this first guy can use the second model of the world, this predictive model, to plan ahead, to to say, I'm going to select an action sequence that is going to lead to a lot of reward and not to a lot of pain.
So,
But
whenever it's waking up, the little neuron, that stands for the agent itself. It's thinking
I
about
have
itself.
one doubt.
It's thinking about itself now. It's just a very simple consequence of this very simple setup.
Let me give you one example. We at Visual West, we are robo-advisor, and we are looking forward to asymptotically approach the bank advisor, which is a very complex issue. He needs to understand all the contexts when you make financial planning, for example. He needs to adjust to different types of customers. And very, very briefly speaking, we reduce consciousness, self-consciousness, to something like a byproduct of data compression and mathematical optimization processes. But many people wonder, when they look at the brain, you have electrical processes, you have chemical processes. Is it really that simple that you just extrapolate the computing resources with the LSTM networks? I myself, I believe in it in a certain way because I do scientific computing, but on the other side, I try to stay at the intersection towards liberal arts. And I can understand when some people question that, if it's really that simple.
I'm going to make you guys take a step back even further, because not everyone comes from the math side of the world. Let me put it this way. I get what you guys are saying in terms of how complicated, and I think we all agree that's where computers are going, but what you're ascribing as emotions and consciousness to me just sound like a really good computer making good predictions. It doesn't feel yet like we're talking about either emotions or consequences. We're just talking about an efficient neural network.
Well, that's the question, if it's really that simple. A lot looks like this, but my concern is that many experts have this tunnel view and they follow Jürgen, which is really great work, but when you look at genetics, for example, you have a random factor, you have mutation. So when everybody is running in the same direction using the same technology, you might end up in a local minimum, but not in a global minima, because other people are not doing complete different things to reach the same level of the same goal, consciousness, or is it a false thinking? I just think that maybe other experts should do something completely different to reach the same goal. Otherwise, we are running in the same corner and maybe we never reach it at the end.
Yeah. Wow. You said a lot of things, lots of implicit questions. So let me just react to one of those. There is no hope that we will achieve optimal behavior. We are all, everybody in this room is stuck in a local minimum, and is far from being an optimal problem solver. And is even far from being an optimal problem solver in a little particular domain.
Yeah.
So all of machine learning is not really about finding the optimal, best possible solutions to particular problems. It's just about improving what you've got so far.
Okay.
And so if you talk about investment advising and automate portfolios, you want to take the existing system and you want to improve it, and you want to use the data from your finance business to make it a better predictor and so on. And you are happy if it's just a little bit better than the competitors.
Yeah.
And this is true for every robot. It's also true for every human. No universal problem solvers among us here. That's okay. So we shouldn't be worried that we are in a local minimum or in a non-optimal part of the search space. That's okay.
Okay.
To explain what a problem solver is doing as it is trying to understand the world and then use this knowledge to become a better problem solver, you don't have to refer to optimality concepts. You can just have a system that improves what it can do now, and in the process becomes a better problem solver, and as a byproduct of that, you get, through data compression, essentially the things that look like consciousness and fear and emotion.
So I want to make sure we get to at least two more things, and maybe we'll get to carry it forward, but I want to take it a step back. Where are we today versus kind of this world? Where are things today relative to where it's very clear that they're going in terms of not just consciousness and emotion, but also true decision making and so forth? Talk a little bit about what the state of the art is today versus what's clearly on the path a couple of years out.
Yeah. So 95% of all AI, commercial AI today, is really about something that is rather limited in many ways, which is called supervised learning. And each of you has a smartphone in your pockets, and on these smartphones you have neural networks that make your life easier. For example, they understand your speech, or they translate your questions for Alexa, or they translate sentences from one language to another. And all of this can be done through a limited form of deep learning, as it is called, a limited form of machine learning, which is called supervised learning. And there you have a teacher that tells exactly on a training set to the system what it should do in response to these incoming data. For example, one thing that is, should I mention that? One thing that is coming here from this place, from Munich, originally is called the long short-term memory network, the LSTM, which is now on 3,000 million smartphones, and it's doing the speech recognition for Google, or the translations for Facebook, 4 billion translations every single day. Is anybody on Facebook? Anybody on Facebook? Is nobody in this room on Facebook? Nobody? Okay. All right, okay.
They're all using their deep neural networks right now.
But there's, for example, the LSTM is also used in this Microsoft bot that was in the news like a year ago, which became like super racist. And there I have people started to say like, we should hard code ethics into AI.
Well, and that was going to be my next question.
There's my issue that if you try to hard code it, yes, you can have some basic rules. But on the other side, first question, would you end up with like a Vatican AI and an Iran AI and a China AI? And the second question, even if you hard code an ethics into to a machine, I mean, my own values are already very contradicting, and it's for everybody else, so it is already very difficult. So, but even if you're going down and you define a clear set of values that are not contradicting each other, will the machine one day start to question these values by themselves? I'm looking at China, who tries to give a value over the whole country now with their system, which looks a lot like this episode from the Black Mirror, by the way. But one day, maybe the machine, when it's more conscious, it will start to notice the values that you put on me are not really helpful for certain things, so it stops to deprioritize some credits for certain people.
Before the AI is even questioning the values we teach it, are we even teaching the AI good values right now, or are we just transmitting a ton of our human bias?
And my question is, should we do that? Because what is a value? Even some Nazis thought they have values from their point of view, and they can go completely wrong. So should we leave it to the machines to create their own values, and not that we start to hard code something in it?
I don't believe in these country or company-dominated values, or I don't believe that they are going to be super important. I don't think that we will have one set of values for China, and another one for America, and another one for Bavaria, and so on. Instead, what you will find is that within these subsets of the world, you have lots of people who have very different ideas of what's a valuable value and what should be done. Most nations are not uniform. Within most nations, you have lots of ideas, competing ideas about what's good and what should be done. And I'm rather optimistic that this whole AI business is going to be a really democratic business, because once we have figured out this very short algorithm that allows us to optimize all kinds of goals and optimize all kinds of utility functions, then I think in hindsight it will turn out that it's really simple, just 10 lines of code, and any high school person can implement it by themselves and use it for all kinds of different problems, and that's what they are going to do, and it will be a huge amount of different values that are going to be pursued. So it's not going to be just one company or just three companies.
The white guys with hoodies in Silicon Valley who just implement the values that they see from their little perspective and force that to all the other people. You say you will have several different AIs that compete with each other, and everybody can put their own values.
I want to challenge it a little broader. I mean, you mentioned in America there's a wide range of values, and I would totally agree. I think in China there's probably a lot of values among the people, but they're not getting codified. My sense is today at least, and if it's not going to be this way, how is it going to shift? It's the Chinese government wanting to make sure its AI follows its value, which is control and a common good above the individual will. In the US, I would argue it's a subset of the population who's actually got the skills and the money to do the coding. If that's not the case, how does it get democratized? Is it the computer itself somehow absorbing the values around it? I'm not really seeing...
It should. There
should be, but
automated machine learning which use their own, mathematically saying, hyperparameters and starts to set their own values and changes these values when the environment changes, when suddenly there's an asteroid coming in or a climate catastrophe. The machine can change the values, and not that a little government of, I don't know how people are in the party there, in the Chinese party, or some guys with hoodies in sorry, like that, yeah, in Silicon Valley, yeah, who makes that for everybody. And I don't trust people in a certain way. I have a certain mistrust towards people. In that way, I'm more optimistic that machines will be able to find an optimization of different values and not.
So Jürgen, do you think the machines do better than the people that program them, or are they limited by the people that program them?
Oh. There's one important thing which I have learned over the decades, which is if you want to build a smart machine, then you better give it the freedom to invent its own problems and to set itself its own goals, to better figure out how the world works and what you can do in it. Like a little baby is playing around with its toy or toys, inventing its own experiments to figure out how gravity works and so on. We have had the systems which are equipped with something I call artificial curiosity, which is really about inventing your own experiments, not necessarily given by a teacher, by the parents or something. And only a system that has the freedom to explore the world like this is going to become a more and more general problem solver. Well, in principle, we have had that since 1990 or something. It's just very small brains and our little agents back then, computers 1,000,000 times slower than today, and so on. And they are still, even today, they are clearly smaller than the brains that everybody in this audience has. But it's not going to stay like that forever, because every 5 years we are gaining a factor of 10 or something. The important thing is, however, to realize that an intelligent system must have the freedom to create its own goals, and these goals will not necessarily be those that the teachers
Do you think China's going to program a computer that's going to give it the freedom to overthrow itself?
Yes, because they want to be number one in AI, which means the only chance they have is to give their system the freedom to invent their own goals and problems, like scientists also have the freedom to invent their own questions and figure out the answers for that. And only those scientists who are living in countries where this is allowed have a chance to unfold and develop their talent.
Okay, well, I'm afraid we're going to have to leave it there because we're out of time. I do think there's a lot for all of us to think about in terms of where we want to take these computers. How much freedom do we give them? What do we teach them? So thank you for helping us start that discussion. If you enjoy these questions and others, quick plug, I do a daily newsletter for Axios. You just go to getlogin.axios.com and my neural network will be in your inbox every morning. So thank you very much. Thank you, Alexander. Thank you, Jürgen.